There have been 3 or 4 different people suggested things on the list. So the most recent one was EAP AKA. OAuth was another one. Yes, Hannes has just volunteered. That's great. But I mean, I guess that's a topic for the research group. I mean, if people want to do work on something, then somebody has to step up and say, "I'll do work on something." So this is a great time. If you think it's a useful thing to do, then please approach a microphone and or jump in the queue if you're remote and say what you think. Colin.
Hi, is this working? Yeah, Colin Perkins. It was a little difficult to hear you because of all the noise from the back before they shut the doors just there. Yes, I mean, I think this is a good thing to do. I think having sample problems is good. The IMAP stuff seems a reasonable choice as far as I can tell. I perhaps wonder about the levels of complexity, because that's a moderately complex problem. And I wonder if we should perhaps have a much simpler noddy problem to start with to get things going, and then move up to things like that to introduce people to the tools.
Sure. Mark?
Hi, Marc Petit-Huguenin. This is the right way to
okay, next time I get it right.
So yeah, I started during the hackathon to do the formalization for IMAP, and in fact, this is not complex, right? So this is a huge spec, but it took me probably a day to understand how it works. So I don't consider it that complex, especially the search subset is not that complex. So no, I would not. By comparison, I would put SIP more complex than IMAP is because of the complex transaction that we have here. So yeah, I think it's a reasonable size. So far, I didn't find any issue. Well, minor stuff in the ABNF, but I didn't find any issue. But I'm still working on this, and it will take a few weeks at least to do that.
Yeah. Good.
So the question, I think, is how many sample problems do we want? Maybe 1 isn't enough. Maybe 3 is too many. Do people have opinions on how many sample problems and of what complexity? No one in the queue?
That's Mark.
Yeah. Mark is back in the queue. Colin?
Hi, please. Sorry, I should use the queue. I mean, obviously we don't want too many, because that just there's an infinite amount of choice and no one knows what to do. I think it's useful to have a range of problems at different complexity levels, and there are some which are just, I suspect they're just for helping people get used to the tools, and we don't expect them to be anything that's difficult. It's here's a tutorial problem that you can solve in an afternoon to demonstrate that you figured out how to use the tools at all and got the basics going. And then there are more complex things like perhaps the IMAP one that help you show something about the problem space and start tackling something that's at least approximately a real problem. And then you've got the full-on, well, let's validate TLS 1.3 style problems. Mm-hmm. And I would suggest we perhaps one or two at each of the sort of difficulty levels of things.
Yeah. Cost.
So just to sort of respond to Colin there, I mean, I think something of the complexity of TLS 1.3 is that's not a sample problem anymore. that's like
sure,
that's a PhD.
I realized I was being flippant.
But I think one of the other things people mentioned about this kind of scale of effort was one of the things we might be targeting is something that a professor can give to a grad student and say, hey, why don't you run our favorite method over this thing. So it's that level of scale, I think, is probably one of the good things. I don't know if there's something that's so simple, it's only a few days work. I'm not sure if that would be possible or that interesting.
So there is a very standard problem in formal analysis of the Needham-Schroeder protocol, which you can prove is broken in about 4 minutes, but it's not very IETF-y. So is it worth coming up with a new IETF variant of that, or should we just say, for the real basics, we'll just accept non-IETF protocol?
Oh, we're just chatting. It's a research group. We're not making any decisions, so it's gonna. Phil.
Yeah, Phil Humbaker. Channeling my college tutor, who did a few things in formal methods. I think that what he will be saying right now is, what are you going to prove? Now, it's one thing to write a specification, but he kept going on as what are you actually proving with it? Because until you actually have a proof, you've not really done anything more than write a spec in a language that doesn't work.
Yeah, the properties that, in this case, IMAP has are in scope for the work.
But also, again, I mean, I think one of the points of this is not necessarily to find out, that IMAP search is broken, or not broken, but to try and work on the usability of some of these methods. So to give people a thing that they can attack. Chris, I think you're next.
I guess maybe similar to Phil's, but not quite the same. So I know a lot of these tools can actually build running code, maybe not production code, but running code afterwards. And would we want something that can be tested that way at the end of it? Would that potentially be part of it or not be part of it? As a toy, right? Like, so from the IMAP case, can you actually do, take the formal version, generate something that can do a search, and does it work?
So yeah, I mean, I don't think we particularly have that as a goal, but I mean, somebody applying a method to the sample may or may not, depending on their tool choice, have that as a goal.
I mean, to some extent, what's the definition of a usable tool? Like, as I think maybe we do care about, and is that some part of it?
Yeah, it's a demonstration.
Richard Barnes, just raising a couple of, I was thinking about things of low to moderate complexity that could use, that might be interesting. Try out your modeling tool things. The OAuth working group has this Depop thing, which is doing asymmetric keys bound to OAuth tokens. So that doesn't inherit some of the complexity of OAuth, but not all of it. And it's got like a pretty simple authenticate your HTTP request sort of thingy, which is pretty straightforward. The other thing that came to mind is HPKE, which is obviously already had some modeling done on it, but it's kind of similar in scale to the Needham-Schroeder stuff that Jonathan mentioned, though hopefully less broken. But it touches touches public key encryption, it touches symmetric encryption, it touches key derivation. So it's a bunch of things that would be useful to kind of play with in a modeling tool.
Yeah, and I think a point, I can't remember who made it on the list, was that it might be kind of good if one of the sample problems is kind of more cryptographic and the other one is not, like the IMAP search was not, so, because there's different sets of tools and so.
Yeah, and the Depop one is kind of interesting because it's a little bit intermediate, because it's partly crypto and it's partly looking at like HTTP integration.
Cool. And were you volunteering Hannes to do that work again?
Yeah, absolutely.
Great.
Alessandro Ghedini, Cloudflare. As someone who has basically zero experience with formal methods, it's sort of hard to know, whether a specific sample problem would be like too hard or, too easy. But I can, based on experience, for example, from the quick standardization process, there's been a few instances where, someone realized, oh, if you, I don't know, drop a packet at a specific instance, then suddenly the connection hangs. And in those cases, it basically required someone to just like mentally go through all the possible, packet flows and whatnot. So having something that could be used for even if you don't, not necessarily modeling the entirety of the quick protocol, but there's like smaller bits and pieces that could potentially be done independently on their own, and they could be useful sample problems. It's maybe a bit too late to actually change the quick protocol if a problem is found, but or even like you model it and then you realize, oh, it's actually fine, like we did a good job. But again, it's hard to know like what a good sample problem would be, because I wouldn't necessarily know how hard it would be to actually model.
So I guess in my head, a kind of a useful sample problem was, that's the scale of it is like either something that an academic could say to a grad student, and why don't you spend some time looking at this, and it might produce a paper or it might produce something that we could publish here. So not something that should take 6 months.
I mean, there's also the question of at what resolution, right? If you just want to measure is there a deadlock in quick? If a packet drops, you can model quick in a very, very simplistic way. But whereas if you want to check security properties, you have to measure all the way down to like, what strings are being put into which hash functions.
Sure, but again, I mean, I've never had grad students, so
interns, it's the same.
Well, okay. I'm not sure that's selling the concept of being an intern.
Joran Schäfer, for the document to be complete, I think you need to define the question, to define each of the samples well. And right now it's not really defined. For security protocols, we sort of know what we want to prove, but for IMAP search, I don't know. I think we should say it out loud.
Sure. Good idea. And our next volunteer.
Well, wait until you hear the example I'm going to use, and you'll know not to volunteer me. If you want really simple and like grad studentable, it seems like something closer to retransmit timers or slow start for TCP might be interesting because it's well understood, but I don't know that formal methods have been applied to it to do verification. And you would at least get an answer where you could point to it and go, yeah, this formal method did the right thing because we understand the problem space so well. But that would be closer to what Colin's talking about in the really simple, if you wanted to try it out example. It would be a very boring grad student problem.
Mark?
Marc Petit-Huguenin. So if you want a really simple problem, a really simple protocol to formalize, in which by accident I found an issue, it's TFTP, right? I send an email there. There is a problem inside. I explain what is the problem. I know TFTP since, I don't know, 20 years, and I never saw it, right? And I believe nobody saw it really, or people will say, oh yes, yeah, we know about this, but we never care. But this was really simple. And how I found it, in fact, is because I needed an example to put in one of my documentation, right? So I said, let's use the simplest protocol that I know about, protocol, not a standard, which is lockstep, right? A lockstep protocol. And I said, it should be easy, right? And I tried to work on this, and then it didn't work, right? And this was because there was a small problem. So if you want really a minimal problem that is not specific to security, I think this is a really good example. And I know that there is a bug in it. So let's see how many people can find also the same bugs that I found, right? And the solution is obvious also. So.
David Skenazy?
David Skenazy, transport enthusiast. Another example that comes to mind after hearing Pete was the bug in TCP cubic. I don't remember all the details of it, so hopefully I don't get this horribly wrong. So cubic at first didn't have a spec, it was just a Linux implementation. And it was in there for many years until when the Quick team at Google decided to put cubic in Quick. They lifted the code out of the kernel, put it there, and wrote a battery of unit tests, because that's the great things you can do when you're not in the kernel. And one of them found this really intricate bug where if you get into the sequence of events, you would end up like sending huge amounts of packets. And then they did some telemetry or figured out that it was happening like at world scale, and was like, oops, just sending lots of packets that were pointless. I wonder if that's something that could also be one of those examples of trying to model the cubic steady state and reproducing this.
I guess the question links to Yaron's question of what do you bind, what's the property you're proving there? And is, because you've got to know what questions to ask. So is the question like, what's the maximum number of packets I'd send? What would the security property, oh no, sorry, what would the performance property be? Yeah.
That's a great question. I have absolutely no idea.
So I'm not an expert in formal methods or usable formal methods, but a couple of things that occurred to me during this discussion, right? One, things like IMAP, you know, are maybe great from a protocol point of view, but it does get down into, it depends on what's in the user's box, right? So you end up in the space. And so that actually got me thinking down another road. So I'll give you another example of a protocol that actually would be interesting to study that is very simple in nature, but has the same problem at the end in terms of content. You eventually boil down to something that's outside the scope of the spec. And that's the simple network management protocol. So SNMP, because it is a query response, it's very simple. And the interesting thing about version 3 with the user-based security module, it was developed in the IETF, meaning it's not based on a formally proven protocol. So if you found anything there, it would actually be really, really bad. But you know, it was developed by IETF geeks, not by, you know, Yuri Blumenthal was, I think, the primary person behind it, and he has decent crypto chops, far better than mine. But it really was sort of a one-person design.
Colin.
Colin Perkins. Listening to the discussion, I sort of wonder if not only should we be describing sample problems, we should be trying to write down the list of types of questions you might be trying to ask about protocols.
Yeah. Mark?
Marc Petit-Huguenin. Last time, I promise. So I would like to go back to something which is a U in UFMRG, right? The usable part. And this is really the thing I care about, because what I care about is to be able one day to have people from the IETF side coming and say, yeah, this is not as complex as I thought. I really would like you to explain to me how to do this thing, because it seems useful, one U, and usable, and another U, right? If we have too many examples, we will not be able to compare different methods to see if they are usable. I said this when we were remote, I don't remember when, is that usability is in the eye of the builder, right? What is usable for me is not usable for someone else. It depends on your training, it depends on your experience, it depends on a lot of things, right? Nobody can convince me that something is usable. Only myself, when looking at example, I can say, oh yes, this looks like something I know, and this other thing looks absolutely alien, and it will take a long time for me to understand it. So this is why I believe, I understand that we cannot have one example for each system existing out there. But if we have one example per system, then it defeats the point of be able to compare this thing, right? I use the example of Rosetta code, right, which is a great site if you want to know what a new language is about, right? You go, you see how the code is written with the language you know about. You look for the new language. You say, okay, yeah, it seems that a certain class of problem can be solved very easily in Prolog and not in C, right? So you have your comparison of usability. Yeah. If we have too many, then we will not be able to reach this goal, at least that way.
So I think we want to wrap this up in a few minutes. So Lucas. But the next question I'm going to ask is who wants to actually do stuff? Because that's so it's great having ideas, but it's even better to do stuff.
Hi, Lucas Pardew. I definitely don't want to do stuff because I wouldn't know what I'm doing. So I think, yeah, just throwing ideas out there. Something I'd love is a formal analysis of the multipath quick work that we're doing, but that's super complex and probably way beyond scope. But we can have that discussion later on. For other kinds of problems, I wonder, maybe I don't recall hearing it, but things to do around compression keeps coming back and hitting us. Thinking about stuff to do with like the crime vulnerabilities a while ago that are maybe the intersection of performance and security and these kinds of things. But I'm no expert there. But also related to compression, things like the QPAC compression scheme and HPAC as well that were designed to be not the crime and breach vulnerabilities, but that the complications with QPAC that were added by Quick's kind of or global ordering of streams, etc., blah, 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 and the possibility of deadlocks in that scheme, and that even if the protocol is done correctly, the implementations of that are still, like, I think people who've implemented it have hit the hard edges of it.
Right. So yeah, thanks everybody for lots of good ideas about what we might do or what somebody else might do. Anybody got suggestions as to how we turn that into somebody? I mean, the ask here now is not to actually go and apply some formal method, but just to describe a problem in a way that somebody else can come along and apply a formal method to. So is anybody willing to kind of say they'll think about even documenting something like that? Some of the good ideas you had? No, we're not looking for that now. We're not looking for people to apply methods. We're just looking for somebody to describe a sample problem. An IETF relevant, not too complicated thing, such as people have been mentioning for the last 20 minutes. Hannah's. Great. So minute takers? Write down Hannah's volunteered. Depop. Okay, cool. Is anybody else willing to I mean, you're not committing to doing something for 6 years here. You can give it a try. It doesn't work. It doesn't work. That's okay. 5 years might be okay.
We have someone in the queue.
Joshua.
If you're sending audio, we can't hear you.
It's good to know for what, though. Yeah, Joshua, if you could, if you're having audio problems, you could put it in the chat, or we can come back to you later. Okay. All right. Well, we got one volunteer, and Mark has already sort of started to help, so I'm not unhappy. Okay, so I think we'll move along. We'll move along to Gergely and his presentation on Isabel. So Gergely, I'll pop the slides up now, and then I can give you control over them, or I can move the slides along for you if you prefer. Just 1 second.
Do you want me to do it?
Oh, you're doing it. Yeah, go ahead. So Gergely, would you like to tell us to move the slides on, or would you like to have the controls locally? He's sharing them
Okay, so okay then. Okay, so can I start?
Yeah, go ahead, Gary.
Can I start?
Yes, please. Go
Okay,
ahead.
so today I would like to talk about Isabel's Weekly for Internet Research. And from the feedback I got on the mailing list and of the list, so I would not claim that Isabel is a panacea for everything doing internet research, and for sure there are better tools for specialized problems like security protocols, but
So we've lost your audio.
Gregory, we've lost your audio here. Whose idea was it anyway? Oh. He's no longer in the meeting room.
how can I next slide, please?
Yeah, you're back now. Yeah.
Jonathan, can you send me the next one, or I? Oh yes, yes. Okay. So in general, formal methods are mathematics about definition, theorems, and proofs. But of course, in such a short time, I would talk about only definition and theorems. So to how to actually model things, because the proof language of a theorem prover is a different thing. But hopefully in IETF 118 in Prague, when I will be present in person, I can talk about more about formal proofs and how to use, because using a theorem prover is not only about doing proofs, but probably finding counterexamples and things. So ask questions at any time. Next slide, please. Okay, so of course there are experts on formal verification in this group, but for those who not, so the main thing, of course, about formal verification is to deduce formally to basic inference rules. But that's just part of the story. But also our goal is to deeply understand our systems. And an example is just somebody asked whether TCP was modeled, especially slow start, by formal methods, and I just sent you a paper on the list that TCP was actually modeled by Isabel by Peter Sewell. You can check. Okay, some extra reading for this talk would be these old papers, and again answering some feedback. So I do not claim that now I talk about up-to-date, latest formal verification tools for cryptography. This is a general method, the Isabel theorem prover, and it was some security analysis was done way back in the 90s. So, but for an introductory example, I just wanted to have something that I can talk about 20 minutes. So, and these papers are on the wiki page of the group. Okay, so Isabel is a software. It's actually a nice feat of software engineering because it works on Linux, Intel and ARM, and Windows and Mac OS. Also, it does not use extra amount of memory. So for a start, 4 gigabytes is enough, and even for larger projects, 16 gigabytes. So your usual laptop would do the thing. only for very large projects like the SCL4 microkernel verification, you would need more, but usually you don't work on that in the beginning. There's another website called the Archive of Formal Proofs, which is an important thing. If you would do anything, then for first you should go there and do a search what kind of things has been done previously. And also a software engineering feed that Isabel is a moving target, but if you upload your code to the Archive of Formal Proofs, then the maintainers maintain your code, so it will work with the latest version of the software. For a graphical user interface, there's a version with JEdit, a Java-based editor. That's the more developed one, but of course, with the popularity of Visual Studio Code, we have an interface with that as well. You can try out. It's in the bundle. Okay, let's start with how could we do protocols. So Possum's work is about using the Dolev-Yao model, which is of course not the most specialized modeling of a security protocol. So we treat cryptographic blocks as working perfectly, which is of course not true, but at least we have a modeling of the protocol, not the underlying cryptographic primitives. For those with security protocols, I think these must be familiar. We have names for agents. Then technically we have integers, which could be time steps. We have nonces, which are unguessable random numbers. We have keys, which can be shared keys or public and private keys. That's later in the model. Hashes, compound messages, and of course encryption. And this is the syntax of Isabel. On the right, of course, there are comments in the code. Okay, then we model agents. And in a simple model, we have a server, which of course we trust. And in the middle of the slide, you see that server is not among the bad or compromised agents. We have friends. Some of them are compromised, so lost their keys, or somehow the spy got their keys. And of course, they're the spy, the intruder. So our protocols should be secure even in the face of compromised agents. So we do not live in a perfect world. And then we have events, and later on we model the protocol as event lists. So what happens on the network is much like you are using Wireshark to see what's going on your Ethernet network. So somebody says a message to another agent, somebody gets the message. So you can model man-in-the-middle attacks where the other party does not get actually your message, but the spy sends him some message, and then notes when somebody notices some message. Okay, this is a difficult thing starting. So in the model, we have algebraic operators. So always we have a base set age, so something we learn from the network. And then with this parts operator, we have a magic eye. We see even encrypted things, but no keys. So, but somehow we know what's in the traffic. Then we have ANAs. We see only things that are public or those we have key for. So you can see the premises that some encrypted message is part of this set, and then the inverse key of this key is part of the message set. Then we can decrypt the message. And at last, we can construct things by the synth method. If we have some message and we have if at the key, then we can do things, and we can basically do anything. at the very end of my slide set, if you download it, you can see the whole definitions for these. So you can construct anything, but no nonces or keys. So we cannot invent other people's secrets. Okay, so this is an algebraic theory. And of course, there are many properties that you can actually prove with Isabelle. And then the knows predicate, which from an agent name and some traffic on the network, what you can actually learn. And of course, you can reason about what someone learns. And there's a special spies predicate, what the intruder can learn from the traffic. Okay, now how do we protocol? So a protocol run is a list of events. So what happens on the network. And the protocol itself is all the possible traces. So that is an event list set. And there's a crucial thing here that if the spy sees something on the network, then he can say anything that he can construct. So formally, Sint Anna spies, but in plain English, we see something on the traffic, we analyze it, and then we can construct anything from it. And the spy can send anything using this method. Okay, of course, I don't go to the details of TLS, but someone familiar with the protocol can recognize the names of the steps. So it's a large inductive set. So for inductive sets, the natural numbers can be seen as an inductive set of having 0 and having the successor of a natural number. It's much like this, but of course more complex. And later on, you will see that a crucial thing about using a theorem prover for such definitions is that it automatically creates an induction theorem that you can actually use. And that induction theorem is difficult enough, so you could not do it in pen and paper, but with an automated theorem prover, you can actually use it, and it will check all the corner cases. And that's why on the first place you want to use some formal methods. Okay, let's see an example. So there are 3 parts of my slide. So at first, we have a definition what a certificate is. So a certificate is something that we encrypt with the private shared key of the server, some agent name and its key. So we bind together the name and the key. And then defining the protocol, that's the middle part of the slide. If something happened on already in the network traffic, then Bob can send Alice this kind of certificate with Bob's public key. And then there will be a theorem about TLS. If a certificate appears in the traffic, then we can be sure that the public key of Bob is this KB key. Okay, another thing, again, the definition of the protocol. So if something happens, so when we say B prime at the bottom of the slide, then we are not sure who says it, some other party. So it might be Bob, might not be Bob. And also that A already noted some type of message. Then Alice will say Bob this kind of certificate with the private key of A, and that would be part of the network traffic. So that's how the protocol participant should work. Next slide. And then there's a lemma. that if we see such a certificate in the traffic, then it was indeed A who sent this certificate. Of course, the proof is detailed and not part of my talk. Okay, well, a little bit of that. What you see is an apply script. So we work on the goal state, which sometimes we do, sometimes we don't. We have basic inference rules, like revmp and s substitution. We have then automated proof search, and the last one is the most important, which makes it possible to do proofs and protocols, an induction rule. So you could not even see this induction rule in one page, probably, because of this complexity. Okay, how to use Isabelle? Anonymous reviewer asked, how do I actually use Isabelle? It is not possible to detail this in a short talk, but what you do is you write model as definitions, like this inductive definition, and we state our properties as theorems. There might be some very simple sanity checks, and you can start using nitpick. Nitpick is a counter example finding tool, and then you can or you should write lemmas when you try to prove something. So but interacting with the prover, you will see some proof state, and you realize that your theorem prover does not know something that is obvious to you. So then you should state your lemma, prove them, and then you can prove your main theorem. And Sledgehammer is an automation tool that uses many other automated prover. For many problems, now it gives you a simple solution. You will see an example. And this is a relatively new phenomenon. So, okay, let me go. Okay, so this is how it looks. So the previous trust cert verify lemma live, and then your cursor is against after some proof command, and you will see a proof state, and you can think what kind of thing you should do next. You see the induction rule and with some automation. Okay, so we would try induction, because that's the obvious thing to do. We have 15 sub-goals, which again does not fit one page. But then next slide, we can do Sledgehammer, and in a few seconds, it will give us a few automated results. You just click on the result, and it will be copied into your proof text. Of course, this does not solve all the 15 sub-goals you had, but the first one, obviously. So now there's quite an automation, which was not the case when Poisson developed his modeling. Okay, what I suggest, if you are interested, is that this concrete semantics book, which is not quite the thing you would use for internet protocols, but the first part of it contains, I think, a nice introduction to doing formal proofs with Isabelle. You can download the whole book as a PDF, and also it is a book that is automatically, not automatically, but they update it for the latest version of Isabelle, and the new one is coming in the weeks. Okay, another feedback was that, okay, but this is an old work of Poisson, and it uses the Dole-Viau model. Crypto primitives are perfect building blocks, and of course there is space for inspective crypto building blocks. There's even work with Isabelle, so-called crypt-hole, which defines a functional language for expressing games-based proofs. So there is work all around with Isabelle. Okay, I do appreciate that for crypto protocols there are very good specialized tools like Tamarin and things, but here at the usable formal methods, probably we would like to have a tool that can be generally used, and I think transport protocols can be modeled as well. And as I said, I just sent a paper about modeling TCP. And Tamarin, I read a dissertation about Tamarin, and it has nice automation, and they reported even 2 orders of magnitude of speed up on using modeling protocols, and they claim it is an engineering tool, so not to think too much about modeling. I think even in Isabelle, you can do much better than Posen did 20 years ago, because there's proof automation with IceBuck, and there are many things out. And also at IETF, you are concerned with the implementation, and what you can do in Isabelle is to do a code extraction. So you have a model, and then magically you would have some ML or Scala code or Haskell to work with. Okay, next one. So do you have any questions?
Thanks, Gary. So if anybody has questions, just jump into the queue, or Jonathan.
So I think I asked this on the list also, but you put that Isabelle, that Tamarin got 2 orders of magnitude speed improvement over Isabelle. For quite a lot of the models I do, Tamarin takes hundreds of gigabytes of RAM and many days of compute time. Adding 2 orders of magnitude on that would be very, very expensive. Is there a reason I should pick Isabelle over Tamarin?
Well, if for latest security protocols, probably no. I don't know. What I wanted to say that there's a space for research doing Isabelle. Of course, the question is who has the manpower and the costs of it. I don't know, or what kind of research can be done in an academic setting.
Colin?
Hi, Colin Perkins. I mean,
hi, Colin.
Hi, I'm coming from this from the point of view of someone who does not understand formal methods, and I can sort of see that I can describe my protocol declaratively and use this inductive thing to do it. Where I think I would struggle as a protocol designer is figuring out how to go from type of protocol specification we write in the IETF to the set of declarative statements about the protocol, which you can then put into the modeling tool. And I don't know how to get over that gap. I don't know if this is an education thing or if there are standard techniques for doing it to sort of get things into the format that they can go into these sorts of tools. Is this something where there's typical ways of doing it that we can elaborate on in this group, maybe?
I hope so. So I think I should address this in my tutorial in November, but let us exchange mails about it, because to tell the truth, I don't know too much about the other end of the gap. So let me have some examples of what kind of protocol specifications you would like to formalize, and see there how can we do it.
Yeah, I mean, I guess this comes back to the sample protocols that we
Yeah,
were
yeah.
discussing before. But I do think one of the challenges is going to be trying to bridge that gap. That's the comprehension gap between the two different ways that the communities work.
So yeah, I would say, Colin, there definitely is standard ways of doing various things, but then there's also a whole lot of black magic woo-woo nonsense that we do, and I was quite sure why it works, but it seems to. So maybe there's a couple of bridges to gap there.
Yeah, I mean, there's also just such radically different ways of describing protocols in this type of formalism versus the way the IETF writes the specifications, and it's a pretty big conceptual difference in the way of working.
Hi, it's to answer Colin's question. It's actually pretty simple. And leading back to the discussion we had earlier about the samples, if you actually look at the security protocol, you first have to abstract things, that the whole exchange a little bit, and sort of like this is the modeling phase where you need to figure out like what's actually relevant for you. And take that out and describe this in whatever your favorite formal method language is. And then typically, so once you got there, you have something that is very similar to what you would describe in a message exchange in the protocol that you are talking about. So that will actually be quite accessible to IETF people, in my opinion. It gets far more complicated if you, in my opinion, if you look into other types of problems that some people also mentioned here, like when it comes to cryptographic algorithms and you want to demonstrate something there, then you obviously are into a totally different realm. Or if you actually want to provide or demonstrate deadlock-free properties and liveness properties, which I think is a completely different sort of area here, or performance aspects, which is again different. But if you stay with the former one, you would typically have a number of protocols already described, and you could sort of look at those and start from those. And most of the work is actually finding out like what in your protocol you really want to focus on. And then the goals, the security goals, are often also very similar to other protocols looked at in the past. Like if we talk about protocols like TLS or the mentioned OAuth, DPOP, or like the Needham-Schroeder protocol, etc., etc. So it's actually, those are really pretty straightforward, in my opinion. There's not a lot of fuss about them. So I think if we start with them, I've given tutorials in, for example, at the OAuth security workshops, like where in like 2 hours, I think people got the basic ideas. So it's not that complicated. But of course, if you start like pretty much from scratch, like with Isabel, you will spend days just writing things down for what I call for no good reason.
Almost like you have an opinion now.
Thanks. So again, and thanks, Gergely, for staying up late. I think it's like 2 a.m. or something for you now, is it? Really appreciate it, and look forward to hearing more about that. So I think we had one last kind of agenda item, which is more, I guess, an announcement at this point, probably. So we discussed on the list plan at the last meeting the idea of having some kind of Sunday training tutorials before Prague. So I think what we plan to do there is to try and see, a number of people said that they'd be willing to kind of offer some training. So I think we'll set up a call with those people in the next few weeks and have some discussions with the Secretariat here. Hopefully the idea would be we'd have a room, we can record it and spend, I don't know, 3 or 4 hours, whatever we get available. So I think if you're interested in this topic, then planning for Sunday before IETF 117 would be a good thing, and we'll try and make that happen.
The other thing I was going to ask the room, are people more interested in, I think I proposed this on the list, an intermediate or masterclass level tutorial, or are people more interested in the beginner stuff? Because one of the usability aspects we've had mentioned is there's no intermediate level training available anywhere.
Okay, so I guess given that we're at a minute to go, we'll take that to the list. But yeah, so we'll probably set up a call with people who said they would try and help for that in the next number of weeks, depending on availability. And if you're interested in that topic, then just send a mail to the list or to the chairs, and we'll include you. And I think that means, Jonathan, for the third time in a row, your If Time Permits presentation is not permitted. So thanks, everybody. I think we're at time, and we'll discuss things on the list. So thank you. Thanks, Hannes. I look forward to seeing your. Oh, you can now. Okay, I can vaguely remember that. Yeah. I suspect the lack of time is going to be a problem. Even if you have 4 hours, like it's going to be.
Only if it doesn't want to do, well, that's why I've been quite keen on not doing a beginner thing, because there's been 4 or 5 options for that, and they're all on YouTube, on how to use Tamarind 101. And then no one's ever been here's how you go from this most basic Tamarind, here is TLS. But yeah, it would be super if you
Yeah, so we'll probably do a call about this. I think also Mark.